Okay, so as I introduced you before, in the first part of the course, we will take some of the contents that also Dr. Buratti presented you, in particular about quality of masonry, how to also make experimental testing about masonry, how to estimate the strength of your masonry for the purposes, of course, of evaluating the vulnerability, for example, of a building, which can be a regular building, it can be a castle, and of course the kind of masonries, for example, will be very, very different. Then this will be roughly the first date altogether. Then we will go from the material to the elements. When I say elements, I mean walls, for example. So when we talk about masonry strength, is the strength of the material itself, but of course knowing which is the strength of the masonry is not enough, because what is very important is to know which is the strength of, for example, a panel of a wall, depending on the kind of possible mechanisms that can occur. So when we go from the material to the elements, we go from masonry strength to that we call capacity model for masonry walls. Capacity, you probably remember this word from Buratti, is an open word that means not only strength, but is also deformation capacity, for example. Because especially when we talk about seismic actions, it is not sufficient to know which is the strength of a panel, but also its deformation capacity is very, very important for many, many reasons that also Dr. Buratti discussed, and we will go in. After this first part, we will, still talking about vulnerabilities, we will talk about how to assess the vulnerability of a building, which can be the methods of analysis that can be at different scales, that can be, for example, finite element modeling or macro element modeling, etc. With every method has some advantages, has some drawbacks. We will discuss about it. And then when we talk about vulnerability, the main thing that we will have to consider separately are that one thing is the behavior of a masonry wall in its own plane, and a completely different thing is the behavior out of plane. A good behavior of a masonry building is when the building is working as a box, but in order to be a box, of course, the walls must be connected together, and there is some interaction between the behavior of the panel in its own plane and the behavior out of plane. But this division between the two behaviors will be much better described in the following. Then we will close the part 2 talking about what is the meaning of intervention level when we talk about existing building. Intervention level means that especially when we talk about seismic loadings, we can just improve the behavior of a building, or we want that the building is safe as a new building. And of course the objectives are completely different, must be defined, And of course, starting from this point, we will go then in the other part of the course that will be how to do this kind of interventions. So with this paragraph, we will, in summary, close the vulnerability evaluation part of the course, and we will go into the intervention part of the course. It will be about 40% of time in the first part and 60% of the course for talking about different kind of intervention. So we start from the beginning now. Probably some aspects you also know, but it will be not time lost. In particular, what is quite important is that when we have existing masonry building, when I typically use existing, which means that is, of course, not a new building, but when we talk about the masonry building, the word existing means also typically old. Old means that is done with masonry quality, which is not the kind of masonry that we use now, for example. And especially for all the buildings, for all the masonries of buildings, the behavior of the masonry is quite different from that you may expect if you just think of the classical rules of elasticity, for example. The behavior is completely different for several reasons. So this is a questionnaire that was given to a group of engineers. It is quite interesting, and I always start with it. And the question that was given to the engineers was this one. You have a panel, a masonry panel. The panel is supported over some foundation, which is a rigid foundation, and there is a loading which is applied on the top of the panel. So the question that was given to the engineers was, okay, what is the behavior of this panel? Which means how the concentrated load is distributed as stresses in the panel, and of course the load must have some path from the point of application to the foundation, and the foundation is a rigid block, it is a rigid foundation. And the questions that were, the cases that were said were, okay, you can say case A, B, C, D, E. Okay? Then the engineers replied, and of course the distribution of the answers were that most of the engineers said, okay, the behavior is something between C and D. What are C and D? That, for example, C and D are different just because of the angle of amplitude of that distribution cone of the stresses, okay? It is 60 degrees, which means plus minus 30 in the first case, plus minus 45 in the second case. So the idea for the people that said C and D is that from the point of application of the loading, the stresses are distributed more and more going from the point of application to the foundation. Okay? So if it is 60 or 90 degrees, depends on some issues that we have not discussed. Then there were some people that said, no, the correct answer is A and B, which means that the stresses are not distributed over an area, but they are distributed according, for example, to an arch or two, this is an arch, for example, or two struts. A strut is an area where you have just compressions. Okay? Very few people said E. That is, you have the application in an area and there is no significant distribution of the stresses going from the point of application to the foundation. Just 3% said E. Okay, which is the correct answer? You see directly on the picture. It is the question that was almost from nobody found correctly. But of course we must explain why E is the correct answer with respect to the other ones. I said we are talking about old buildings. So what is a characteristic of an old masonry with respect, for example, to a new masonry, which means a masonry blocks, masonry mortars adopted, used now, for example, for masonry buildings? The main difference is that in old buildings you typically have a bad quality of the mortar. We will talk about what is the quality of the mortar, how to estimate, etc. But just take the concept for now. Bad quality of the mortar, bad quality very often of the assembly of the blocks, that is, blocks which are not assembled regularly. And if these two things occur, bad quality of the mortar and the bad assembly, the mason is not able to distribute the loading. That is, the loading is just going almost straight from the point of application to the foundation. If the quality of the mortar is better, then you go to from E, you go to the case C, then you go to the case D, depending on the quality of the mason, which is better and better. Okay? So the angle of amplitude of the distribution depends on the quality of the mortar. Of course, the greatest is the angle, the better is the capacity of the mortar to distribute concentrated loadings. And so, for example, you can have, if you have just, for example, a wall with a wooden beam on the wall, if the quality of the mortar is good, the load is very high here, but then is distributed and it is smaller and smaller going from the beam to the bottom. But if the quality is not good, you have a concentrated loading, very high pressures all over along the vertical area of the beam. So this is a very, very important issue with the consequences that we will see, for example, in a picture that I'll show you in a minute. Just a few words why A and B are not correct. They are not just crazy answers, because very often we have arch behavior in masonries. But why it is not correct now? Because of the kind of foundation. Because if the foundation is rigid, then there is no formation of an arch distribution of stresses. Because arch distribution means, you see here, that stresses are limited to two areas where that arch is going. For example, if you have columns, if the masonry wall is supported over columns, then typically you have a formation of an arch behavior. Just an example. For example, think about what you can have if you have columns. You have sometimes you have wooden beams, okay, and then the masonry. this is not a case where the foundation of the wall is rigid, because this is a wooden beam, okay? I'm talking about, of course, the upper part. So the beam are, in some sense, the foundation of that wall, but they are not rigid. Why? Because the stiffness of a wooden beam is very small with respect to the stiffness of the masonry. So, in this case, you start having a distribution which is something like an arch behavior, because the beam is weak in terms of stiffness. But the case that was subject to the engineers was the case of a rigid foundation. Okay? So, and finally, because this is quite good also to start discussing freely, what is the difference between A and B, for example? When you have that the distribution, for example, consider this case that I showed you before, that the distribution is in terms of an arch or just two struts, two horizontal, two straight struts. You have an arch typically when you have a distributed loading. For example, this case that I was showing is a distributed loading, okay? Because it is the weight of the masonry, that there is the weight of the slabs which are distributed all over. But if instead you have just a force and you have some for example, consider the case, it is not a real case, but the case where the masonry has not a significant weight. It is, we try to neglect the weight of the masonry. And we have over the masonry a force applied here, then you have a formation of just two straight areas that are distributing the loading from the top to the columns. But of course, this is almost never the case, because the weight, the self-weight of the masonry is significant. So typically, you have the formation of an arch, as I said before. So I started just to show you something that can be quite different, for example, from what you think when you make some elastic analysis, for example. And this is quite important, because from the point of view of models, of numerical models, how to make a model that is able to predict the behavior of a masonry, if you use elastic models, all these behaviors are difficult to capture, okay? So when we will talk about models, we will have just to make some more careful discussion. Okay, this is just exactly the same idea with just a different example. What are the consequences to have localized effects which are not able to distribute over an area? For example, this is one consequence. That is, when you have, for example, the loading due to the application of a beam which is just put on the top of a masonry wall, then you have that the loading is localized in an area, and so if the strength in the area where you have the beam is not sufficient, you start having vertical cracks. Of course, if the loading is able to distribute much better, then the level of local stresses are going down very, very rapidly. So, depending on the quality of the masonry, many problems you can have or not have. Okay? Other characteristics of masonries are that Typically, you consider the masonry as a unilateral constraint. I think that in the classes of Professor Carloni, there was this subject going more deeply than in our classes. Unilateral means, as you see, for example, in this picture, that when, especially here in this area, that when you have two walls that are connected, typically the walls are able to support compression, but they are not able to support significant attractions. Okay? So unilateral means that, for example, in compression, this wall will work together with the other one, but if instead we have some action that are putting tractions at the level of a conjunction of two walls, typically you have a detachment. The fact that you have detachment or you have still some properties of the walls of being together depends on the quality of the masonry in the area of the corner, of course. If the walls are connected or not. If they are connected, there is some possibility, of course, of supporting some traction. If they are not connected at all, you have just this behavior. Okay, so quality of the masonry then is a fundamental issue. So it is, and you, as you see from this initial picture, the quality of the masonry can be very, very different depending on the age, on the period of construction, but depending also on the area, on the region where your building is built. For example, masonry buildings in the area of the Pianura Padana are completely different, for example, from those that we have in the center of Italy, for a very, very simple reason, because of course, especially in the past, people used the materials that were available in the area, except for exceptional buildings, palaces, for example. Then there was also the money to bring the material from other areas, but instead, for example, in the Pianura Padana, typically you find bricks which are lime-made, whereas, for example, in the center of Italy, you typically have blocks, which are just blocks taken from the rivers, for example, or from the mountains, etc. So the quality of the material depends really a lot from the area and also from the period of construction. There were some periods, for example, where there was some kind of city expansions, like those that we have, for example, we had in the last 50 years. For example, when the people came from the hills, from the mountains to the cities. There was a period of where all the villages, all the cities in the area where the commerce was much easier, they grew in the period of, for example, 18th to 19th century. So there were periods where there was a growing and a need of having more and more construction, and then, of course, the quality of those constructions was lower and lower. As exactly the same as it occurred 50 years ago. And, for example, you see here two completely different kinds of masonry. In the case on the left, you have very regular blocks assembled. Possibly, those blocks can be also without mortar if the blocks are very well cut and very well assembled. In the second case, this is a typical case. This picture is taken from the earthquake in Umbria, but it is the kind of masonry unfortunately, that we typically have in the center of Italy, so Umbria, Abruzzo, in all the mountain part of Italy along the Apennines. So, how can we categorize the kinds of masonry? There are some rules at the beginning to try to give I can say, not a quantitative evaluation of strength, which is a different thing. Quantitative means that we must have some values of compression stresses, etc. That we will talk about in few minutes. But when you go in a site, and for example, this kind of categories are introduced by the Ministry of the Beni Culturali to make some categories of kinds of masonries without thinking about the quality from the numerical, from the quantitative point of view. But it is very important to understand, okay, but it is a good quality, medium quality, or bad quality of masonry, just to have an idea. And there are some rules that are quite interesting and very often used. They evaluate the quality of the masonry depending on 5 parameters that are still evaluated from the point of view of engineered expertise. It is not quantitatively. But I will show you some pictures to show that it is quite a scientific way of proceeding. Anyway, for example, you see here, but we will go into the details. For example, if we have horizontal mortar layers, and which is the shape of those layers. This is the first parameter. The second parameter is how are organized the vertical layers. They are aligned, they are quite well staggered, you must estimate. Then the third parameter is the shape and the dimension of the elements, in particular of the bricks. If you have great big blocks, typically the quality of the masonry and the strength is greater, especially if the big blocks are also very well cut. If they are small, it is just almost like a gravel of a river, so the quality is much worse. So shape and dimension is very important. Then very important, presence of transversal elements, those that we call in Italian diatoni. Okay, there are also translations, nice translation. I like better to call transverse elements because with that name you can also discuss also with people from out of Italy, which are of course very important. You see here, for example, that these are, in this picture, these are a wall with 2 main leaves. If the 2 leaves are connected, the 2 leaves may work as a wall. If they are not connected, of course, you must have a separation of the walls. Separation means that the slenderness of the walls is much greater, and etc. So connection is very important. And then finally, the quality of the mortar, of course. But it is not the most important issue that I want to remember you. Why? Because it is much more important how the masonry is organized. That is the shape of the beds, which is if the blocks are regular or not. Because if the blocks are very regular, you can also not have mortar, and you have a good strength, because of course you have the compression of the weight that is helping you to support, for example, horizontal forces. So these are 5 criteria, and depending on which is the judgment that you will give on those, you will define the masonry quality of type A, which means good quality, or B, intermediate quality, or C, poor quality. Okay, about the importance of connections, this is a picture that is showing you what I was saying before. Of course, if you have a connection, the wall is working together. If you don't have connection, of course, and especially, for example, this is a kind of mason with 2 leaves and an internal core. Of course, the 2 leaves, if are not connected, the real masonry supporting the loading is only this one. But they are very, very thin. If they are not connected, of course, the possibility of having instability of the wall, even if the strength is sufficient, but they can be unstable. And they can be unstable both in the presence of a loader which is applied directly to the wall, or, as often can occur, when you have, for example, slabs that are not supported over the wall thickness of the wall, which is the typical case. Okay? You see from here that if you are in this case with the slab which is supported just over the first 20-30 centimeters of a wall, you are not distributing the loading in the wall thickness layer. You are able only if the 2 parts of the masonry are connected. So connections are very, very, very important. Before going into the how to classify the masonry, this picture is quite interesting because it's showing you how can be the behavior of, for example, a connection of 2 walls if you have a good quality, intermediate quality, or poor quality. If you have a good quality, you see that, for example, if there is some action taking the transverse wall apart, okay, talking about what Professor Borardi said, this is that we call local mechanism, okay, you remember, but we will go into details for it. But it is very important that if they are connected and you have a good quality of the masonry, you see that the crack that will be formed is inclined, and this angle of inclination is quite large. It can be up to 45 degrees. If you have an intermediate quality of masonry, this angle can be smaller. For example, I can say 30 degrees. If you have a very poor quality masonry, it can be closer to 0. Remember this picture, very similar to the picture we started with, okay? So you remember when we said typically in all buildings you have this situation, so we don't have the possibility of distributing the loading, and if we have connections, the angle of connection of the transverse wall with respect to the longitudinal load is close to 0. Why it is important to have a larger angle, so a larger area? Because of course when you talk about local mechanisms, the weight of this area with respect to, if you make, for example, some equilibrium of moments, okay, of forces. These are the forces giving you instability. This is a stabilizing force. So the larger the angle, of course, the larger will be the weight of the masonry, which is giving you a positive contribution. So quality of the masonry is very, very important for all those reasons. But how to classify? As I said, there are 5 categories, and these are the names that are given. And for each of them, for example, presence of horizontal mortal joints. The horizontal joints the joints are really horizontal, so this definition is respected, yes or no? It can be respected, not respected, or partially respected. Of course, there can be also intermediate cases. So for each, but then I will show you some pictures, which is much easier. For each of the 5 categories, you must give a judgment of how is the quality of that masonry. For example, we start off with the first one. Horizontality of mortar joints. Respected means, you see in this picture, that the joints are almost horizontal, almost along the wall. Partially respected means, as you see here, that there are some areas where you have a good joint, then the joint is going at a different height, but still you have some alignment of joints. Not respected is this one, that is, the blocks are almost organized almost randomly, not completely randomly, because of course the people had still, so they knew also in the past that also if you have blocks of different sizes, it is much better to have some good alignments. But of course, if you have of different sizes, you can have, for example, as you see here, 2 blocks that are equal size, but then you have small blocks here, etc. So the first case is it is respected or partially or not respected, and then you have to judge this as a technician. Vertical joints is also very important. Respected, stagger or vertical joints respected means that the vertical joints must be separated. For every layer, you must have that the vertical joints are in different positions. In the first case, it is respected, partially respected. Not respected means that the poor guy that did this wall just put the blocks almost randomly, and then you can have more than one layer of blocks where the vertical joints is still the same. Why it is very good to have that the vertical joints are not in the same vertical line? Because of course, if this is the case, you are able to distribute the loading. Why? You start loading this element, for example, then this element is supported by these 2 elements. These 2 elements are supported by the other 3, etc. So it is, if instead you have the vertical joints that are going vertically, you are not able to distribute the loading. So this is very important, at least as the quality of the horizontal joints. Shape and the dimension of the blocks. If the blocks are of greater dimension, of course it is better, because the inner quality, the inner strength of a block, of course, is much higher than the strength of the final masonry. So greater blocks are much better. So in this case, shape and dimension are defined by two adjectives. One is if they are regular or not. The other one is the size. For example, you see these are regular and big size. These are regular and medium size because you have blocks smaller. Going into the last one, irregular and the small, which is of course the worst case. Okay. Then there is, let me see, there are two other categories, very, very simple. The first one, the fourth one, is the presence of connection elements. So either they are present, partially present, or not present, you have three categories. And the quality of the mortar. If it is a hydraulic mortar in good condition, or it is a lime-based mortar of a poor quality, are three different categories. So how to judge the quality from all those categories? The criteria that is used is quite simple. For each one, you see, there are some grades. 210, for example, 210, 1.51, 0.50, etc. And depending, for example, you have 2 points from the first, 2 from here, then you have 1, then you have 0, then you have 0. You make the summation of all those points, you find a number, and then there are some ranges for this number to say, okay, if it is high, it is a quality A or B or C. So this is, of course, not a quantitative evaluation, because we are not saying which is the strength of the masonry, but it is very, very important to classify from a first insight the kind of masonry that you have in your building. If there are some schemes, some examples, those are reported in a big manual that was prepared by the Civil Protection Agency in Italy, with a lot of people all in the whole Italy. These are written in Italian, but I just wanted to show you how they work, which is the most important point for me. These pages are organized, and for example, people that have to make some project that must be analyzed also from the point of view of preservation, typically are required to make this kind of scheme. That is a couple of pictures of the masonry, a picture by hand showing the most important elements, that is how the engineer and what the engineer understands from the picture. Then there is a description of the materials, a description of the geometry, and then there are points to arrive at the quality index. For example, in this case it was 8. 8 is in the category A, for example. Also from, if you start working with this kind of schemes, you also understand very well the differences. That is, what is the best quality of masonry? On the left or on the right? It is quite evident, it is on the left. And of course, in this case, it is A. Here, it is not good, and you see for several reasons. You must make all the classification that we said before, 100, etc. Quality index is 1.5, category is C. So it is quite well working, I can say. Now I go very, very rapidly with some pictures now. the quality can be up to C or D. There is also a category D, which is almost zero for all the contributions. But I just go very, very briefly to show you what can be the differences that you can find in real cases. You can see here, for example, this is one, of course, of the worst masonries that you can have, because you have big blocks, you have very small pebbles, the shapes are very regular, there isn't any scheme of realization of this kind of wall. And, of course, when the sizes of the blocks are so different, there is a lot of mortar, because the mortar is used not to regularize the surfaces, but it is used to fill the voids. So, for example, you can have here some thicknesses of a mortar of 5 to 10 centimeters. And you can imagine that in the interior of the wall, it is typically even worse than that you see on the front. When you have the mortar, which is more than 1-2 centimeters, having so large thicknesses of mortar is reducing the strength of your masonry really, really strongly. Why? Because there is also a different two reasons. Of course, the quality of the mortar in terms of strength is much smaller with respect to the blocks. But also, the deformability is completely different. Of course, the mortar is much more deformable than the blocks. So when you put some loadings here, the loading is trying to follow the path following the stiffest elements. So it is like that the mortar is almost not useful at all, because it is just as the blocks are just put one over the other one over small surfaces. Why? Because the mortar is deforming a lot because of its very low elastic modulus. So this is one of the worst cases that you can have. This also, of course, is a bad quality masonry. In this case, you see from the shape that these are pebbles taken from the river. You see, because they are round shapes. And of course, when you have round shapes, in order to make a wall, you must, you see, fill the voids with smaller pieces, and then smaller pieces, and then there is some mortar. But you don't have any organization in terms of horizontal, vertical lines at all. So this also is a class D case of masonry. Oops. This is going better, you see. Now you start seeing some, at least as far as the horizontal lines is concerned, this is much better. But from the point of view of vertical head lines, this is not a good masonry, because the blocks are like a squared shape, and you see that vertically you have almost vertical lines dividing parts of the masonry. So it is better than before, but it's still not a good masonry. Let me go ahead. Sometimes the masonries are organized with different materials. And for example, this is a technology that was used in the past to improve the quality of the masonry. And there is the reason why it is improved. Even if you start from the beginning, you can think that it is just a strange idea. Consider, for example, the pictures on the left. You see that you have blocks of arenaria, in this case you see from the color, and then every, I can say, like 1 meter, 1.5 meters, there are 2 layers of bricks, and then you start having a new part of the wall still with the blocks on the top. Why those artificial bricks can improve the quality of the mortar, of the wall? This is quite interesting. Also because you must think to the people that these were pictures taken certainly from the mountains, for example, from the Apennines, typically. So, using artificial bricks where the artificial bricks were not produced, it was a cost for the people. So there must be a reason to use them, okay? The reasons are two, and are two very favorable reasons. The first one is that when you use the artificial clay bricks here, you are able to realize like a flat surface, and from that flat surface you start realizing the upper part of the wall. Then you realize another flat surface, and then you start to realize another part of the wall. That is, it is not just to put blocks randomly, but it is a sort of a realization of layers of walls every time you start from a flat surface. Of course, the regularity of the wall is strongly improved for that reason. But there is another very interesting reason, and it is the reason why always you see not just one layer of bricks, but always at least 2 layers of bricks. And the reason is this one. Let me take a white paper. That is, if you just put one layer, and here you have all your blocks, okay, and the other blocks here. If you have just one layer, the strength of the wall with respect to some transverse forces is very, very low, or at least those bricks are not improving, certainly, the strength of the wall transversely, okay? Why? Because there are, of course, there is the mortar between them. Instead, if you put 2 layers, and of course there is some vertical loading over the masonry, where you have 2 blocks, I'm just separating them, because of the presence of the vertical loading, there is some friction between the bricks, and friction means the possibility of supporting some tractions in the transverse direction. Okay? So, with 2 bricks you are able, of course, the vertical loading is giving you friction, and the friction means possibility of supporting traction. So this realization is improving significantly the quality of the masonry in this case. You see in these two pictures. These two other pictures are typical of masonries realized, I can say, in the end of the 19th century or beginning of the 20th century. That is using concrete like something like a concrete beam, but of poor quality concrete, very often without any steel bars. That is just the concrete material. For example, 1 meter of masonry. It is like to realize like a ring beam, but without any steel. Okay? The idea is just to replicate something similar to the case that we have on the left. Of course, the strength of that concrete transversely is a low quality strength. But it can be sufficient, for example, to avoid some overturning of some walls, etc. Every time you have some traction strength, of course, you are going, let me go here, you are going from this case to this. You are able to this when you have some traction capacity, okay, at the level of the wall. For those, for example, the class that was defined was C or B, depending on the size of the blocks. Another very important aspect in the quality, as far as the quality of the masonry, is how the corners of your building are realized. Which means that you see here 3 examples. Here you have these are walls made of arenaria. Those are blocks that are cut from the mountain. But when you arrive at the corner is very well realized with artificial bricks. And those artificial bricks, you see that when it is very well realized, one is long, one is short, the other one is long, this one is short, etc. Why? Because in this way you are able to make some interlock connection between the end part of the wall and the inner part of the wall. Of course, to see better how the corner is organized, you should see in a section, because it is the best should be to have, for example, that this is one block, for example, this is the other block, this is the third, that is, they are put in this way, okay? Why? Because in this way you are able to have a good connection between the wall number 1 and wall number 2, but also because this is in one direction, this is in the other direction, you also have interlock with respect to the inner part of the wall. For example, this is how this corner was realized, and the people also used, in that case, different color tuff to make some architectural good good-looking aspect of that realization. But what is very important is that the corner is regularly realized, and you have blocks in one direction and the other direction. Why the presence of those elements in the corner is so important? Because especially when the quality of the masonry is very, very bad, the end of the wall, of course, is a weak point of the wall. Just think about what can be having blocks that arrive up to the end of the wall without any organization. Of course, you must have that the water, the rain is taking out parts of the blocks, etc. And very few years, if you don't have nothing in the corner, in very few years, you must destroy the wall. But this is one reason. The other one, of course, is that, as I said, when you have a good interlocking between the two walls, that interlocking typically is able also to preserve also the walls. These two pictures, for example, are taken from the earthquake in L'Aquila, and you see here that the quality of that corner was so good that it was almost the only part of the masonry that was preserved. There was the corner, there was a little part of masonry on the two sides, but then the other part of the wall was not able, for example, to support the earthquake forces out of plane. But the corner was much stronger than any other element. On the other side, look, for example, at this small house that was restored, but it was restored almost only from the architectural point of view, that is, without any injections. So they just closed the layers of mortar with a new mortar, but inside the quality was very, very poor, and especially in the corner was very, very poor, so that every time, if you don't have anything, any good realization, the corner is, of course, a weak point for the building. In particular, in this case, there was also the corner of the roof, which was supporting over the masonry, and in this case, you see that there was a full collapse of the weakest part of the building, which was the corner. If instead the corner was realized with big blocks, very well organized, this will be instead a strong point for the construction. Then finally, we can go to very well organized masonries. You see from here, sometimes also without any mortar, as you see from here. But the good quality is because the stones are very well cut, very well, same height, for example, you see, very well organized also in terms of vertical joints. And this is, of course, very easy when you have tough stones. You know, these are the stones that are cut directly from the ground in the southern part of Italy. For example, you think about in Puglia, for example, or in Campania, for example. In those cases, you can cut directly the shapes of the blocks as you want. And of course, they have the same height and the length that you want. Just a few pictures also to go instead to clay bricks and masonries. And you see that here I put together completely different blocks. For example, this one is possibly an old masonry, and this is the kind of masonry that masonry that is typically used, for example, in the Pianura Padana. Then, of course, in the centuries, it was the quality of the blocks was improved, not significantly, but it was the quality of the mortar that was improved. All the other ones, of course, these are new artificial blocks for new constructions. What is that I want to put to your attention here is that also when we have new blocks, new bricks, the quality of the masonry can be good or not, depending especially of the percentage of holes. Typically, for the Italian guidelines, 45% of holes, which means that which is the percentage in area of the holes with respect to the full dimension of the block. If it is smaller than 45%, these blocks are considered to be used also for structural purposes. If it is greater than 45%, they cannot be used for structural purposes. So if you have those to realize walls, for example, you see here or here, even worse cases, or here, for example, the same but put in the other direction, that is not with the holes going vertically, but the holes going horizontally. Unfortunately, sometimes you see some small constructions made in this way. The quality of the masonry must be considered of the lowest category, because these are not structural materials. They are blocks with much more voids than clay material. We go ahead for a few minutes showing some other cases. Sometimes there are masonries which are called framed masonries. Especially this is used especially for high quality buildings like residential buildings for families, for important families, etc. They understood very well, of course, that using some concrete-like material. I use a concrete-like in the sense that it is not our concrete, of course, but it is small pebbles, sand, and some concrete-like aggregate to have some strength. There was the idea of realizing, as you see in this picture, some framed-like masonry where you have these horizontal layers which are at the level of the slabs, and some vertical layers which can be, for example, where there is a transverse masonry wall. Of course, these connection elements are able, even if there is no steel, of course, because this is not a reinforced concrete structure, there is no steel, but they are able to give you important improvement for all the reasons that we already discussed. Talking about masonry buildings in our area, I show you some pictures of what we found after the earthquake in 2001. 12 in the area between Modena, Reggio Emilia, okay? Not in the cities, you remember when we had the earthquake. And what was unexpected, I can say, is that the quality of the masonry there was very, very bad. For several reasons. I want to show you these pictures because very often when you say, okay, clay bricks, we think about to this masonry, this kind of masonry. But this is not, this is not always the case when we talk about the masonries that are 200, 300 years old. For example, this was a building realized 150 years ago. And you see that, yes, there are the bricks, but they are mixed together with a mortar, which is not a mortar, it is just a sand, and with a very bad aggregation scheme, just because they had to realize a thick wall, because there were 4 or 5 floors. And when you use clay bricks and you must realize big walls, how to organize them, it is not so simple. They must be all of the same size, of course, and then they must be organized in a given way in order to be able to have a good quality of the masonry. If you don't do that, you must have something that you see here. Or, for example, very often, this is what we found, this one we found in Emilia, 2 leaves or 3 leaves, just because you must have a greater thickness, but without any connection. Of course, if you don't have a connection, you have all the problems that we discussed before. Or, for example, other problems related to some new intervention that just cut part of the masonry, putting some beams, etc. Or, for example, you see here, this is a wall realized with the blocks, with the bricks put in this direction instead of the other direction, because they had to do 25 centimeters, and 25 centimeters, it was much easier to put the blocks in this way. But of course, you can imagine that here the vertical heads are almost aligned because of the small dimension of the blocks in the transverse direction. Finally, and then we make a break, few more pictures about the quality of the masonry in the area of the earthquake. Another important issue about is the quality of the mortar and the quality of the bricks. For example, for the bricks, not all the bricks are the same. Good clay bricks must be cooked, of course, but very often we can find in poor quality masonries, we can find uncooked bricks. When I say uncooked, it means just bricks that are realized just putting some pressure and not cooking them. Of course, the strength of these bricks is probably 1/5 or 1/10 of the strength of good quality bricks, cooked. And for example, when this is an example of a building where I was involved in the restoration, typically we find uncooked bricks in the upper part of a building. Why? Because, of course, they were cheaper, the uncooked ones, and here the upper part of the building is not important for structural reasons, so the people used just bricks just to close the building. So it was not important if they were cooked or not. So we typically find in the upper layers of the building very poor quality masonry, and especially poor quality bricks. Why this aspect is important? Because when we must make an intervention to this building, for example, for intervention for seismic purposes, the masonry is important up to the level of the wood beams. So also this part of the masonry must be able to collaborate to make the box behavior of a building. Box behavior, I'm using the words that also Professor Buratti certainly used, but we'll go into detail now, we just talk about the material. So also the upper layer is important for our construction, even if it was not important for the construction at that time. Then this picture is also interesting to show you what you can find in existing old buildings in terms of heterogeneity of the materials and of the wall. For example, probably there was some opening here in the past, then the opening was closed, and there was the opening in another part, then there is also some an arch here, I don't know why. And this was a quite a regular building. It was a building that you can find isolated building. There was no idea of that it was a building realized in different periods. You can imagine in a really historical building the difference in the inhomogeneities that you can have. Sometimes also the inhomogeneities are due to recent interventions. This is, for example, a very bad realization of a plant, electrical plant in the building, just cutting almost half of the thickness of the masonry to put the cables of the electrical system. Of course, when you have, for example, a seismic action, then every time you have a reduction of the thickness of the wall, you start having cracks, and the vulnerability is strongly increased. Sometimes also you find instead some good things. For example, this is, you can see this, which is not so easy to understand what it is, but these are wooden planks put at the level of the end of the structural construction. That is, the people knew also in the past that having something which is able to carry horizontal forces, of course, will improve your construction. So they didn't put a steel tie, for example, but they use, for example, a wooden plank. And the wooden plank, of course, it is interrupted here, and very often they put the plank. I'm just putting now, looking at from the top. This is the other plank, and some steel element just to close, to give some connection between them. Then that was the final layer of the structural system of the building. Then they put the beams over it, and then they closed the building. So this is some, I can say, some old idea of what we will want to do now, very often. It is to make connection between the walls, etc. And people did in the past using wooden planks. Okay, these are other pictures. I'm just closing, for example, with what can be the meaning of having some, for example, pipes in a masonry. Of course, in the past, the only way of heating the rooms was to use some pipes, and pipes then were closed, probably after you didn't see nothing because you put new plaster, etc. If you have an earthquake, for example, in this case, we found a lot of vertical cracks. And the only reason when you have horizontal forces of having vertical cracks is that there is some discontinuity. This is the most common discontinuity that you can have. Okay, now we stop for a while because after the break we want instead go from a qualitative evaluation of the quality of the masonry to some quantitative, that is in terms of strength and testing methods.